Hello again. As you know, I am Eli, the computer guy, over here for everymanit.com, and today's class is Introduction to Programming. So programming is when you sit down at a computer, you type out a lot of text or such, and that turns into Angry Birds or QuickBooks or Office or an entire operating system. If you are going to be in the technology field, you do not have to be an expert programmer, but you should understand how to do some programming. So whenever you think about programming, when most people think about programming, again, they think about Windows 7 or Office or QuickBooks or these really big, massive programs. Well, in reality, like with what I use, you can create very small programs in order to do very specific tasks. So right now, the videos that you watch on Everyman IT are provided to you from a little 15-line script that I wrote. So I wrote this little 15-line script with some things called variables in it, and whenever you come to one of our pages that has a video posted on our page, that little 15-line piece of code runs and you can watch our videos. So what I want you to understand is, when you do programming, yes, you can create these massive Windows 7 operating systems, etc., etc., etc. But the reality is you can create much smaller programs to do very specific tasks, and that can be very, very useful for you as a technician. So when I worked back for one of the enterprise companies, we had 200 new servers that were going in. We were installing 200 new servers for our server farm. Well, every single one of those servers needed a little edit to the registry to allow something to happen. So again, I was able to write, a 5 or 10 line script that would literally go out, and on every single server it would automatically change that registry key in order for us to do what we needed to be done. So when you're thinking about programming, again, don't always think about the big stuff. There's a lot of little things that you can do. So this class today, we're not going to be going into actually writing functions and all that kind of stuff. We're just going to be going over the basic things that you have to understand if you are thinking about programming. So we're going to be talking about things like programming languages. We're going to talk about the difference between compiled and scripted languages. We're going to be talking about APIs and SDKs, prototyping, pseudocode, the types of programmers. So if you're interested in becoming a programmer, there are different types of programmers out there. So we'll talk about that, and then we'll wrap up with some final thoughts. So this, don't worry. You don't have to put your thinking cap on. This is going to be a very easy class. We're just going to do an overview of what programming is and give you some of the basic concepts that you have to understand before you start programming yourself. So let's talk about programming languages. So most people, when they think of programmers, they just think that any programmer can program anything. Like, programmers are programmers. Programmers program? Yeah, that's kind of what they think. If you know how to do programming, you can do anything. Well, just like every other profession in technology, programming is actually divided into a lot of different sub-professions or sub-careers. The reason is because basically what programming does is you as a programmer write out in a type of code that's called human readable. So you type out, if x equals 2, then print 12. You type out what you want to have happen. And then the programming language then turns that into something that the computer can do something with. So you type in what's called a human readable language, and then either the compiler or the script interpreter turns that into ones and zeros that the computers can understand. So remember, a computer only understands on and off. 1 and 0. It does not understand if then loop x equals. It doesn't understand that. It understands on and understands off. So what you're doing is you create you're programming something called human readable, and then that gets turned into ones and zeros. Now, when it gets turned into ones and zeros, different programming languages allow this to happen in different ways. So if you want, let's say, create device drivers, so you're going to create a driver for a modem, you would probably use something called C++. That is used for doing device drivers. If you were going to create a web database application, you would use a programming language called PHP. So this particular language is best suited for sending and pulling data from a database. So think about programming languages the way you would think about any other program that you use on the computer. So you would not go into QuickBooks to write a report. You probably couldn't even do it if you wanted to. Just like with programming languages, you could not write a device driver with PHP. PHP is used for web-based database applications. That's all it can be used for. You can't use it to write device drivers. It simply can't do that. The same is true. You wouldn't go into Word to draw a picture. It's just not built for that. So when we're talking about programming languages, again, programming languages are like any other application you would use on the computer. Each programming language is used to do a specific type of program. So PHP is used for like I say, web-based database applications. You can program for Flash. So, all those fancy graphics that you see on websites, there's a programming language that allows you to interact with those things. If you wanted to create an application like QuickBooks or something like Word, you might use a programming language called Visual Basic or the Visual Studio. If you were going to be trying to create programs that are cross-platform, they can run on Linux and they can run on Mac and they can run on Windows, you might use a programming language called Java. Why? Because Java allows you to do that. So the main thing that I want you to understand with these programming languages is each programming language is designed to do a certain set of functions very well. So when you are deciding to write your program, basically what you have to do is you have to decide what you want your program to do. And then once you figured it out what you want it to do, then you figure out the language that you need to learn or you need to use in order to create the program. So don't think, oh, I'm going to learn PHP and then I'm going to write my own operating system. PHP, again, it just doesn't do it. And the main thing with programming languages to understand is what you're going to be doing is you're going to be taking what is called human readable code. So you actually type out with a text editor or one of these compilers, you type out what you want the code to do, and then that compiler, or what's called an interpreter, turns that into ones and zeros, ons and offs. That's all the computer cares about. So that's the basic thing to understand with programming languages. A lot of people get confused. Remember, just like any other application, a programming language is built to do specific tasks. You would not use QuickBooks to write a report. You would not use Microsoft Word to draw a picture. It's just not built that way. Same way with programming languages. PHP, web database applications, HTML, creating web pages, Java creates cross-platform programs. So the next terms that you should understand when we're talking about programming languages are compiled programming languages and scripted programming languages. So what does this mean? Well, basically compiled programming languages are the oldest programming languages, and basically what happens is you write out your code, if this happens, then do this, print this, etc., etc., etc. You then open up a compiler. So a compiler is an application, it's a piece of software you'll have on your computer. You then feed the compiler your source code, so that human readable code that you just created, you feed that to the compiler. The compiler turns that into ones and zeros that the computer understands, and then it spits out a program on the other side, so an executable file. So you put in all this text, the compiler turns all that text into ones and zeros and spits out an executable program. So that program you can then double click or however you run it on your computer and it will run that way. It is now a compiled program. That's what compilers do. They turn human readable text into compiled programs. Then there are scripting languages. What scripting languages do is you don't actually compile the code. So you write out all of your code. So, if this happens, then do this, then print this, you write that out. You then simply put that text onto the server or computer that is going to be running the code. You install something called an interpreter onto the computer. And then that interpreter reads the code and then spits out the results to whoever is using the program. So if you ever hear of batch files, Visual Basic Script, JavaScript, PHP, HTML, any of these types of programming languages, you actually sit down at a text editor, you write out all this text. You put that file onto your server that let's say we're talking about a PHP program. So when I write PHP programs, I write out all the text literally in Notepad. I then upload that to my web server with a file association of .php. On my web server, I have PHP installed. So when somebody goes to my PHP script, that PHP interpreter reads the file and then does whatever it is that file says should happen. So the main thing to understand when you're talking about compiled languages or scripted languages, compiled languages mean you take all that human readable code, you dump it into the compiler, it spits out an executable file. So the file it spits out, that's all just ones and zeros. Scripted languages, everything remains as text. You install an interpreter onto the computer that is going to be running that scripted language. So you install PHP, Visual Basic or Windows Script Host, something like that, onto the computer. And then when you run the program, that interpreter will read the code that you've given it and then provide you with the results. So this is something to understand between compiled and scripted computer languages. Now the next terms I'm sure you've heard a lot about, if you've been following the technology industry lately, are APIs and SDKs. So APIs are application programming interfaces. SDKs are software development kits. What are these and why are these important to you? Well, companies, let's say Facebook or Twitter or Tumblr or any of these types of things, they do very specific things. And in order to grow their influence in the world, they want you, average people, to be able to create programs that can either push or pull data to their sites. So like with Twitter. Twitter is the most popular one for APIs. So you can create a program that either sends posts to Twitter, so it shows up on Twitter, or pulls posts from Twitter to show up in whatever web-based application that you are creating. Well, the way that your program can do this is through something called APIs, Application Programming Interfaces. So what this is Twitter or Facebook or MySpace or any of this, they have a closed environment. They have a secret sauce. When you create a post onto Twitter, you create the post, you hit submit, and then it goes off to Twitter and something happens, magic happens, right? And then, it shows up on your homepage. Well, the thing is, Twitter, to prevent hacking and to prevent problems, they don't want to tell anybody about the secret sauce. They don't want to tell anybody how their program actually works. So what they do is they create what are called APIs, and these are basically points where your program can connect to their program and they can exchange data. So basically, any of these APIs that are created, you can interact with. If they're not created, you can't get behind their wall. So basically, like Twitter, you can do a basic program that would say, write or print the last post from Eli Computer Guy. And so you would write out a line of code that would basically say, get last post from Eli Computer Guy and print on my particular website. So what happens is you can interact with those APIs. They're called application programming interfaces. You don't get into their secret sauce. You can simply push and pull certain data. The main thing to understand with these APIs is one, the vendor, Facebook, Twitter, whatever, can change these APIs anytime they want. So Twitter has done this a couple of times to everybody's chagrin. The other thing is, like I say, you have to play by their rules. So whether you're dealing with Google or Twitter, etc., they will come up with their rule book and they will tell you how you can interact with those APIs. And those are the only ways that you can interact with whatever it is that they're doing. The next thing is SDKs, or software development kits. A lot like APIs, but basically, so we have these new devices coming out. iPhones, iPads, this, that, Zooms, whatever. Basically, what SDKs are there kits that allow you to be able to program for the device that you're trying to program for. So they come with a lot of special tools. They come with things like what are called emulators. So emulators are kind of like fake devices. So you can have like a little Android phone pop up on your computer, and you can create a program for that little fake Android phone to make sure that it works properly. You know, if I push this button, what will happen? So these software development kits, basically what they do is they package all the information and all the tools that you need in order to program for a device, and they either give it to you or they sell it to you, depending on who you're dealing with. Sometimes, like for the Android system, the SDKs are completely free. For other systems, they're going to cost you quite a bit of money. But basically, the SDKs, software development kits, are kits that allow you to program for particular devices. So again, APIs, SDKs, at this point you don't have to worry about them a lot, but it's good to understand. So the next thing I want to talk about is the first step in the programming process. So you've thought about what program you want to create. Let's say you want to create some kind of web application. Well, after you've thought that you want to start creating some web application, you are going to want to do prototyping. So what prototyping is where you sit down and on plain old pieces of paper or with a program like Visio or such, you sit there and you actually sketch out what you want the program to do. So basically, let's say we have a program that we want to collect people's email addresses. It's kind of like, with everymanit.com here, we have a little newsletter link. If you want our newsletter, you put in the email address, you click submit, and that submits the data into our database. So if we were going to prototype this on a piece of paper or on a whiteboard, we would simply, draw out, and we would say, okay, I want to have a box, and I want the box to have an email address, place for somebody to put an email address. And above it, it'll say email, and below it, it will say submit. And I write it out, like I say, on a piece of paper or on a whiteboard like this. Then, if this is what's going to happen, then I would write out here, and I would just put for, when you hit submit, that then goes into the database. And that's all you do. Basically, with prototyping, you literally, on a piece of paper, write out or draw out how you want this application to work. And you write it out so that later you can have an idea of how you are actually going to be programming this thing. The biggest problem with programming is that most people don't understand what they actually want to do. So they get, they sit down and they write half a program and they find out that what they've written isn't going to end up doing what they want to do. So they scrap that, and then they write another half a program and then find out that's not what they want to do. So they scrap that, write another program. Basically, the first thing that you want to do is do prototyping, where you draw everything out so that you understand what you want this application to do. Like I say, even this little email thing here, this can probably take 5 or 6 pages just to write out how everything is going to work. So for this, let's say this is the submit the email. So they put in their email address, you hit submit, and it goes to the database. Well then, if we have a report section, so let's say I want an admin page, and then under that I would have a report button. And if I click the report button, that would have to go to the database, and then that would have to print out a report with all the email addresses in it. Basically, this can get really confusing, and we're going to go into this more as we actually start creating programs. But the main thing to understand is all prototyping is on a whiteboard or a piece of paper. You actually just simply draw out. There's no complicated stuff here. You simply draw out how you want this program to work. So once we've drawn out the prototype of how we want our little program to work, we need to start working on something called pseudocode. So what is pseudocode? Pseudocode is when you simply write out longhand how you want the program to function, how you want different operations to happen. So let's say we're talking about this newsletter program again. So we have this text box and we have the submit button, right? So basically, if we're going to write pseudocode for the submit button, so we want to say, when I click the submit button, what do I want to have happen? So we would say, when I click submit, email address in text box should be added to the email database. So basically all we do is we write out, like that, like I said, like this, in longhand, we write out what we want to have happen when we click submit. When I click the submit button, the email address in the text box should be added to the email database. This does two things for us. One, it makes us start thinking about the process that we want to have happen before we actually get into the code, actually writing out the code, and it allows us to decide what programming language we're going to be using. So if this is going to be a web-based application going into a database, I can say we will probably be using the PHP programming language. You know, if I write all this out, I know it's not going to be JavaScript. I know it's not going to be HTML. We're going to get into that later, but basically, by writing the pseudocode, I can say, okay, the programming languages I'm going to need is PHP. The other thing, again, as we go into the more advanced topics with doing programming, is by writing this out before we're worried about actually programming in the language, it's easier to understand the logical ideas of what are going to be happening in this process. So when you write it out, like I say, you can simply think about what you want to have happen, and you're not actually thinking about code right now. So this is very important. So basically, the next step in the process, what you do, the first thing is you think about what you want to create. You come up with an idea. Hey, I wish I could get people's email addresses. Then you create prototyping, where you actually, like I say, on a whiteboard or pieces of paper, you draw out what you want to have happen. Then after that, for each thing that you want to have happen, you would then write pseudocode. And pseudocode, like I say, is just, you just write out longhand what you want to have happen. Now past this is where we'll get into actual classes on programming. So we'll have classes on PHP and JavaScript and HTML. So past this is then where you turn this idea into an actual program, into an actual application. So this is as far as we're going to go today. Like I say, more advanced classes we're going to talk about more. But these are very, very important steps. Like I say, too many people don't spend enough time on prototyping. Too many people don't spend enough time on pseudocode. And if you don't write out what you want to have happen, then it's really, really difficult to actually program this stuff later. So the final subject we're going to talk about today are the types of programmers out there. Because like I say, everybody, when they come into the technology field or the computer field, they say, I want to do computers. I want to do programming. And they don't realize that there are a lot of sub-professions in the technology field. So, if you're going to come into computers, IT, information technology, like I do, well, you can fix computers, or you could fix servers, or you could do networking, or you could do telephone systems, or you could do surveillance systems, or, there's a whole bunch of stuff that all requires its own skill set. The same is true with programmers. A programmer is not a programmer. They all program, but they all do different things. So the first type of programmer, and probably the easiest one for you to get into, is what is called a web programmer. So when you go to a website and all these kind of fancy stuff happens on the website, that is something that a web programmer does. So basically, web programmers program applications that run on the web. Things like grabbing people's email addresses, presenting websites in a certain way, that kind of stuff. This type of thing you can learn at home, and you can actually produce real professional stuff. Like I say, just right out of your house with no real professional training. You just get a few books, you understand how all of it works, and you can go out there and you can start and become your own web programmer. The next type of programmer is more like the programmer, the programmers that you would be thinking about. These people, would be creating things like device drivers, very complicated programs. So basically, with a web programmer, you can create a web program in a couple of hours. Maybe a week, maybe 2 weeks. If you just sit down and do it, it usually does not take that long for most web programs. Programmers, if you're creating things like device drivers for a modem or for a video card, you're creating applications like QuickBooks, Microsoft Office. Those things take a lot of time. So programmers are the guys that just stand or sit in front of a monitor for 8 to 10 hours a day, drinking their Jolt Colas and just writing code. So those are the people, like the real serious programmers. That's what they're like. They would be learning programming languages like C++, C#, Java, etc. Then beyond programmers, then are the highest level of what are called software engineers. So, when you're creating one little program, that takes a lot of skill and it takes a lot of energy. Well, when you create massive pieces of software, you actually need a lot of engineering. You need project management skills in order to make this happen. So software engineers would be working on like these large cluster computers, things like that. So this is basically just a simple idea to give you that there are different types of programmers. Again, you have the web programmers. You can learn this stuff at home. You can create professional stuff, out of your bedroom on your laptop computer. There's programmers. For this, you probably need a college education. You should go off and get a computer science degree. This will allow you to create the programs that you're used to thinking about. Again, device drivers, QuickBooks, that kind of stuff. And then there's the software engineers. Software engineers create big programs. Programs that span, multiple systems, multiple servers, clusters of computers, etc. So that was a class, Introduction to Programming. If you are interested, if you're thinking about doing programming, these are the basic concepts that you need to understand before you actually jump in to doing programming. People want to jump in and they want to learn PHP or C++ or all of these different programming languages before they really understand what programming is about. The main thing that I want you to understand with programming is, just like every other facet of computers or technology, there's different sub-careers of programmers, and the different programming languages are built to do different things. If you spend a year learning to do, C+ programming, that's not going to help you create web database applications. It's just simply not what it's built for. You could spend 6 months learning PHP, but that's not going to help you build device drivers if that's what you want to do. If you want to create robots, PHP isn't what's going to teach you to do that. So every programming language is like an application that you would use on your normal computer. Just like Windows, just like Word, or just like QuickBooks, different programming languages are built to do specific things. You would not use QuickBooks to try to write a report for school. It's simply not built for that. Again, you would not use PHP to write a device driver. You would not use C+ to write a web-based application. Those programming languages simply are not built to do those things. We talked about the compiled versus the scripted language. So compiled is where you take the source code, that human readable code, you shove it into a compiler, and then it spits out this executable file with ones and zeros. So it compiles your source code into a program, versus a scripted language where your source code always remains a text file. So you upload the text file to your server, you install the interpreter onto your server, and then the interpreter reads the code and then spits out the results. So again, like I say, on our web server, it has PHP installed. I upload PHP code to the web server. When you come to our website, the interpreter reads the PHP code and then gives you the results. We talked about APIs and SDKs a little bit, application programming interfaces and software development kits. Application programming interfaces are the points that companies like Twitter, Facebook, Yahoo, Google give you in order to connect with their systems. So they have a whole secret recipe for how things happen in their systems, and they don't want you messing around with that. So what they do is they give you these APIs that allow you to do specific tasks. So if you want to post a post to Twitter from a different application, that application would connect to Twitter through an API that would allow that post to happen. If you want to read posts from Twitter on a different application, that application would go to that API and then pull the post off of Twitter. The main thing to understand with these APIs is you get what the company gives you. So Facebook, Twitter has done this a couple of times. They can change these APIs at any time. It's all up to them. They can give you more or less access basically, by flipping a coin. It's all up to them. You don't get any control over what happens in their systems. Then the SDKs, again, you've probably heard about a lot nowadays. These are called software development kits. So if you're going to be creating applications, like I say, for the iPhone, the iPad, Android devices, Zooms, whatever it is you're going to build, they have SDKs. Basically, these are packaged programming applications that allow you to create programs for those specific devices. We then talked about prototyping. So this is the first step in creating a program. No technical skills required. You don't need to know anything other than how to write on a piece of paper. So with prototyping, what you do is you think about what you want your program to do, and then you actually write or draw that out on pieces of paper or a whiteboard. So you draw it out so you have an idea of what this thing is supposed to look like. Once you have done the prototyping, you then go into pseudocode. So what pseudocode is anywhere you have little buttons on these prototype paper, you would then say, when I click this button, this is what I want to have happen. By writing that pseudocode, you start to logically understand what is supposed to be happening with your system better, and that allows you to decide what programming language you are going to be using, and then it's easier to figure out logical problems when you're not actually writing in the programming language itself, when you're just writing freehand. After that, we talked about the different types of programmers, web programmers, programmers, software engineers. Again, with this, just like programming languages, I want you to understand the career of being a programmer has different subcategories. Again, programmers are not programmers. You don't say, I want to be a programmer, and then you can do everything. That's not how it works. If you want to create web database applications, you learn one set of programming. If you want to create robots, you learn another set of programming. If you want to start creating artificial intelligence, fuzzy logic, that has, neural networks, that has an entirely different set of programming. It takes a lot of time and energy to learn any one of those sets, so you should understand that, they are different career fields. So that was a class, Introduction to Programming. Again, not too technical or any of that. Our next classes are going to start delving into things like programming in PHP and JavaScript and HTML, and that's where you'll get your hands into the code. But right now, you just need to understand these basic concepts, so when we go to writing code, you have an idea of what you're doing.